My name is Raghu HV. I'm working as a scientist D at C-DAC Bangalore. And in this talk, I'm going to give a overview of how the edge computing is going to use in IoT and case studies of based on the applications, whatever that we have done in C-DAC Bangalore. I'm going to explain about that. C-DAC is a premier R&D organization under Government of India and under the Ministry of Information Technology, Ministry of Electronics and Information Technology. And C-DAC plays a critical role for indigenous technologies for national development that includes high-performance computing, software technologies, and emerging areas such as IoT, edge, quantum, all those things we are working on. As a part of this for IoT and edge in this open source context, how it is very efficient, we can look into that. And IoT, as you all know, just to give a brief introduction of IoT. And IoT is an interconnection of the physical devices wherein it is used to collect and exchange the data. And edge computing, edge allows the processing to be done at the nearby nodes. Whenever we have multiple sensor nodes across the location to sense the data, for example, any kind of data, wherein instead of sending the data from all the sensing nodes to the centralized server, what we are going to do is we are going to have an edge nodes, wherein in each of the edge nodes, we are going to compute and process the data at the same place, and later whatever the required information, whatever the filtered information is there, that information only we are going to send it to the centralized server in this case. Wherein how to give an example of that, for example, if we have like 100 sensors in a factory, wherein it's going to sense any fault in a particular machine or not. Only instead of sending all the data at what range it is running, whenever there is a malicious data or whenever there is data that is filtered out and it detects a fault in the machine, in that case only, that information only we are going to send it to the centralized server as an alert to that. And here the open source promotes transparency and collaboration and cost efficiency, as we all know. And these technologies enable smarter, scalable, and more inclusive solutions for the India's needs. And this is introduction of open source in IoT and edge computing. And IoT involves devices like sensors, actuators, controller, and communication over the networks. And edge, as I already explained, and in the previous talk also, they've explained about the edge computing, how it works during the federated learning aspect of it, wherein we are going to, instead of sending all the data to the centralized server, we are going to analyze the data at the edge nodes, so that we are going to reduce the bandwidth requirement and we are going to increase the speed. And the open source benefits, by using open source, we can have an affordability, flexibility, transparency, and the collaborative growth that's required. And these are the IoT technology elements in C-DAC that we are working on. And in the top layer, you can see what are the main integrated applications that we have. And next is the processing tools, whatever that we have developed in Bangalore, C-DAC Bangalore. And these are common network communication protocols and the devices that we have as part of the edge infrastructure. To build the edge infrastructure, what are the devices we have as part of that? I'm going to explain that. First, when we see about the integrated application part, we have Harita Priya, where Harita Priya is developed by C-DAC Hyderabad, wherein they have given the infrastructure for the farmers. It's going to see whatever the soil, the environmental parameters it's going to capture. We have placed multiple sensors. It has been already implemented in Andhra Pradesh. Some of the edges it's already there, wherein it's going to see the soil, the environmental parameters like soil moisture and what's the temperature for that day. Depending on all those information, it's going to sense and it's going to evaluate and give the alert to the farmers wherein what exactly he need to do for that day, what are the planning he can do by using this. So for this, we are going to use the wireless protocols by using LoRa and ZigBee also. Based on that, we are going to capture the information and we are going to sense and we will send the information to the farmers. And next is the Z-LED, that is ZigBee based LED. You might have seen like as we enter the room, if there are no one is there in the room, the lights should be automatically off. Means all those things will be done by the Z-LED. The ZigBee LED is widely, means we are already using it in the supercomputing infrastructure of the C-DAC. We have almost 30 places that comes under the national supercomputing machine. In all those infrastructure, we are using the Z-LED. And processing element, for the processing element, we are going to use by Sumega, that is a cloud-based lab kit and the ML stack. And for the network communication infrastructure, we are using ZigBee, LoRa, and Bluetooth and Wi-Fi, all those things, we are going to use it. And as the devices part, these are the main aspects of the Bangalore activities that I wanted to explain. Here, these are the devices that we have developed in-house. One is C-Mode, UB-Mode, and Wings is a gateway, UB-Sense, and BLE mode. All this I am going to explain why it has been useful. See, I will take these things as a case study, wherein first I will explain about Indus IoT kit. In this Indus IoT kit, that's mainly used for the academic purposes, wherein they can implement their own thing, whatever experiments that they need to do by using this. And this Indus IoT kit is having onboard sensors of temperature, humidity, air quality, accelerometer, ambient light and sound. So whenever they want to build an application over it, and for whatever the required purposes it has been used for, they can use this Indus IoT kit and they can write their own programming for it. And it has a built-in Wi-Fi and BLE for wireless communication. And it has general purpose input-output pins for interfacing with external peripherals and the actuators part. And what open source contribution we have made is C-DAC has made an hardware design, means indigenously developed means Indus IoT board with the schematics. Firmware is open for developers and the startups for them to use it. And they can also modify or improve upon the existing architecture of the Indus IoT thing. And some of the applications of this are smart agriculture, smart classroom, and water and air quality monitoring, home automation. Any kind of applications, whatever they require, they can write a program. It can be used by students, researchers, by everyone. And about the case study 2, whatever the devices that I've explained before, UB mode, Wi-Fi mode, Wings is a gateway. So these are the mode, these are the embedded boards that we have that can be used for, like UB mode is an high performance wireless communication module that's based on the compliant on 802.15.4 standards, and as well as the Wi-Fi mode is for the Wi-Fi based application, wherein it is compliant to IEEE 8.2.11 standards for Wi-Fi related. So these can be in the Wi-Fi mode. It's having a generic sensor interface with multiple powering options are there, and these are the modes are these are having individual applications for each of these means each of these boards, depending on whatever the use case that we are having, we can use these modes, and it can be and you can do your own program for this, and it can be used. And why it's important, and students get hands-on experience with these real-world devices by using these modes, whatever that we are having available, and it's useful for smart city, smart home, and the healthcare infrastructure. Yes. And it's about Vega processor, that is in-house built a processor that under the India microprocessor development program, wherein it is a RISC-V based architecture we have used for the Vega processor and the Aries board. And the Aries board is a part of Tejas 32. As of now, we have used 32-bit SoC that is derived from an Vega. And some of the applications for this I am going to show here that we have used in the drones. Whatever the in-house developed drones that we have, for those drones, this Vega process has been used. This is the history of the Vega processor and the roadmap that we followed. And during 2018, we developed a FPGA-based RISC-V single-core processor. Later in 2019, we moved on to FPGA-based quad-core. And in 2020, we developed Tejas single-core that is 130 nanometers. And in 2021, the single-core with 180 nanometers. And in 2022, dual core with 28 nanometers, and in 2023 quad core with 14 nanometer. And now we are working on like 100 plus cores with HPC and AI converged with the RISC-V and the accelerators that are required for us, because recently that AI is everywhere, right? So we are going to incorporate the AI based features for the processor with RISC-V and the accelerators part of it. And this is about semi-autonomous unmanned aerial vehicle, that's a drone with the Vega processor. For this Vega processor, it's a collaborative project between C-DAC and IIT Indore, wherein the objective is to develop an unmanned aerial vehicle capable of processing data on board using the open RISC-V processes. So, like here we are going, like here I am going to explain about why the open source part that is very much important over here. Here we have used an UAV firmware and Edge AI models that has been done with the open tools that are available. And the processor architecture based on the Vega RISC-V cores. And this is about the Indus copter that we have in Bangalore. It has been developed wherein it is based on the Indus IoT kit that I had explained. By using this, it will be helpful for the real monitoring and the defense purpose, wherein the data is collected from the edge nodes, and with the same nodes we can do the edge analytics also. And the integrated capabilities of this drone's Indus copter is it is used for onboard processing of the sensor data using the same Indus board. Means this Indus board can be used as an edge devices here. And we have developed the inbuilt controller for the drones, and as well as this can be operated by an Android app, and the communication will happen through the Bluetooth or Wi-Fi based. And the use cases for these drones are identify the infected crop zones wherever there is depending on what kind of particular tree or what kind of based on if we want to put any pesticides for a particular tree, it's going to capture the image and it's going to sense and analyze it, and only for depending on that particular place it's going to put the pesticides. So all those things can be programmed over here. and and it is also useful for monitoring the water bodies for the pollution, and it's useful for the disaster surveillance. For example, any defense based applications, all those things, it can be used. And these are the key benefits of the open source in edge IoT. It is cost effective and transparent, and it is customizable, because since we have all the means all the code with us, all the program with us, so we can modify it as and when it is means it is required for us. And the ecosystems, it can be used in academia, startups, and in the government, or anywhere. And C-DAC's open technology vision. We are working on a mission to develop indigenous open source and scalable technology platforms, and it supports nation innovation through Vega, Indus board, and tools and kits that are required for the educational outreach. And it also promotes ecosystem where government, academics, and the industry co-development solutions. And we have a scheme for the startups to collaborate with us, wherein there is a scheme for funding from Mighty also, wherein if they have a very good ideas that can be implemented in that they want to implement in a large scale, all those schemes that we have as part of the government from Mighty. And it also strengthens in national security and economic independence in the digital space. And this is about that was a part of IoT. And in the when we come to the HPC infrastructure aspects, what are the areas that we are working as part of the HPC infrastructure, that is high performance computing infrastructure that we have. As a part of the open source foundation, we have the RISC-V Foundation with strategic membership with them, and Unified Acceleration Foundation with general membership we have. These are the memberships that we have. And apart from that, we contributed for open source initiatives on the GitHub through the compilers and hybrid applications, HPC containers, and whatever tools that required for the visualization of those HPC applications. And summary of my talk into way forward, what we need to do in this aspect is C-DAC initiatives demonstrate the open source technology used in the real world needs in India. And we work from the Indus board to the Vega processor chips that enables rapid prototyping, inclusive development, and affordable deployment. And the future opportunities that we have in this scenario is wider adoption in case of the smart cities and the rural infrastructure, healthcare, and for the disaster response type. And we are looking for more collaborations from the universities and the startups to enhance this and scale all these things. And we are exploring, and we use and we contribute for the open hardware and the software platforms. Yeah, thank you. And any queries, if you have, you can note to me. Any doubts, if you have, you can ask. Yeah.
Thank you.
AI part?
Sir.
So edge computing use case.
AI use cases.
Right? Okay. Here I explained about edge devices. What are the edge devices?
What are the AI use cases which are running on edge devices? I was more interested in understanding them. I mean, if you can explain that. And apart from that, so these, if there are AI use cases which are running on edge devices, are they running on CPUs or like, yeah.
As of now, the edge devices here in this topic edge device. And the AI part I didn't come across here. Here the AI part we can incorporate for the edge devices, wherein, for example, in the initial project which I have showed, Rita Priya, if you see the application stack that I have shown here, Rita Priya, here, Rita Priya, that first application which is there, right? In that, the edge devices are going to capture the information about the environment, like wherein what is the moisture of the soil, what is the temperature, all those information it is going to capture. By using the AI, it's going to process the information. And only whatever the required information that has to be passed on to the alert, it has to gather the information and process it by using the AI. Because farmer may not be able to understand if you are going to send all the data for him. So only by using the AI, only the required for that particular location based. We need to gather and we need to process and we need to send. And apart from that, there are many things that can be done by using these edge devices over there as part of the AI.
I was wondering if, like, you talked about edge computing.
Yeah.
Do you have software which orchestrates the edge nodes, or how does that work?
Here, when you talk about software, we have given the hardware boards as an edge. So software related, it's up to you what you want to build on. I mean, it's on that existing hardware, that infrastructure.
Okay, so as in is there a software that you have in house, or what are you using for connecting the edge devices to like a centralized cloud type of thing?
Softwares that we have, but I don't have the exact information with me regarding the software aspect of it. Here, if you can see, to connect the edge devices, what are the communication protocols, whatever the firmware that are required, all these things, it will be, it is available. That exact information about the software I'm not having.
Okay, thank you.
Yeah, you can email to me regarding that so that I will take it up. Okay, anything else? Yeah.
Yeah, thank you for showing your GitHub accounts and everything. So, but does C-DAC also contribute to upstream projects like Linux kernel or upstream repositories for various projects that we have? It's good that you're showing things in your GitHub, but that's whatever you have done, you're just dumping it out.
Thank you. Thank you, sir.
Are you contributing to upstream as well? Because I have not seen anything on that sort.
Like upstream projects in the...
Like Linux kernel, U-boot, or whatever, or RISC-V support for Linux. These things you guys are using, or Zephyr upstream.
Okay.
Are you guys contributing, or as a policy, does C-DAC have policy to contribute sources to upstream repositories, whichever you are using?
Actually, regarding these upstream projects, we are working as an independent, center-wise. We are working on the embedded operating system part. So to centralize for whatever you have asked, our Director General came out with a thought regarding that. And now
it's not about centralization. Like your developers whosoever are working on these devices, they can go ahead and contribute to the upstream repository so that it's there and it's well maintained. People taking your boards. So for example, you are talking about development boards. So are you opening those development boards, sources to development boards for people to contribute, or even making it open hardware accessibility to universities and labs? That will be very, very commendable if C-DAC can do that.
Yeah, it's already open for the academic infrastructure. We have already sold for around 800 institutes as of now across India.
So can I get the board schematics and all the specification publicly available, which I can use and freely modify and improve?
Sure. Yeah, it is available. It can be used. And if you contact me by my email ID, and I will share the information how it can be procured. Sure.
Thank you. And what about the software contributions to upstream?
Regarding that, as a mission, we are working on as an operating system mission the government of India is coming up with, wherein we are working on developing an operating system for the embedded OS part, which includes from the kernel space also. So as part of that, we are going to contribute for whatever that you asked. Yeah. Yeah. Anything else? Okay. If no doubt, then I will end my session here. Yeah. Thank you. Yeah, Vega processor is a C-DAC one. Yes, yeah. It is an ARM-based processor, yeah. Yeah, thank you.